So far in this course, we've been working toward eliminating uninteresting or highly repetitive code from our contexts by moving test object creation off into separate classes that can be shared across multiple tests. In the last module, we turned our object mothers into object builders. This made our tests more expressive and easier to read, but it came with a price. There's still a lot of repetitive code, it's just in the builders now. It's an improvement over repeated code in every test, but we can still do better. Just as with any normal production code, the first step in reducing repetition should be to identify items that can be moved into a base class. So let's start by creating a base builder class. This will be a generic class where the type parameter is the type of object that the builder will create. Examining the address builder class, there's not really much actual code that can be extracted, but we can at least define the basic shape that all builder classes will have. Each builder has a build method that returns an object of the appropriate type, so we'll start there. The build method will be abstract so that each builder will have to implement it. The guts of the build method need to change for each individual builder, so we can't do anything more than define the base build method at the moment. We can add the object backing field though, since we know its type as defined by the generic parameter t. Note that the object backing field is changed here. Since this is a base class, we'll need it to be visible to the descendant classes, so it's now protected, and its casing has changed accordingly. With that in place, we can now add the WithObject method pair. That appears to be all we can do in the base class at the moment. Let's clean up the existing builders to inherit from the base class. We'll need to add the override keyword to the build method to satisfy the compiler. Since the backing object field is now defined on the base class, we can remove the previous object field and fix up any references. Let's also clean up this condition a little bit. It's currently checking the backing field against null, but the lazy class has another trick for us. I'll replace the comparison with the check of the isValueCreated property of the lazy instance. This property tells us whether or not the function backing the lazy instance has been evaluated yet. So it performs the same function as the null check, only now null is a perfectly valid value just like any other. I'll put some null propagating operators in here for safety since the backing variable starts off as a null and doesn't even have a function to evaluate until it's given one. At this point we've just shuffled some code around, so there shouldn't be any broken tests. The next step in our path toward automatically generating the builders is to divide off the code that can be generated from the code that can't. I'll add a second class definition to the existing country builder class and mark both halves as partial. Partial classes let you split a single class's definition into multiple parts. Normally you wouldn't put both parts in the same file, but I'm using this to make a separation between the parts of the file that need to be created by hand, which I'll keep in the first partial class, from those parts that can be generated, which I'll keep in the second. As we build up the generator, we'll slowly start to eliminate code from the second partial until there's nothing left. The first thing we can eliminate is the inheritance from the base class. There's no need to specify the base class in both halves of the partial. Now let's examine the code we have so far. The fields at the top are not particularly interesting. There's simply one field for each object property, and their types are just the original type wrapped in a lazy. There's no developer intervention needed here, so let's leave them in the lower partial class and move on. The build method is pretty repetitive as well. You're probably thinking, but what about the child relationships? Well, don't get ahead of me, we'll get to that in a minute. The default method is nothing interesting, so we'll leave that. That brings us to simple and typical. Finally, something interesting. These are the methods where a human developer will have to make a decision about which fields belong in which method, so let's move these to the upper partial class. That just leaves the with methods in the lower partial class, and they're very formulaic, so we'll generate those as well. Let's go back up to the upper partial class. You can see that there's really not that much to this class. It's just these two methods. This is the only part we want to be responsible for maintaining by hand. Everything else should be automated so we never have to be bothered with it.